Hello students, good time to all. I am Chandan Kumar Pradhan. Welcome to your YouTube channel Chandan Physics. In this video, we are going to discuss Hartley oscillator. Let's begin. Hartley oscillator is a very popular sinusoidal feedback oscillator which is used to generate high frequency waveforms. Let us proceed its construction. As it is an oscillator, it is a combination of amplifier plus feedback network. We have an NPN transistor as common emitter mode configuration. Emitter RE, bypass capacitor CE, at base voltage divider bias, R1 R2, another capacitor CB, at collector that is radio frequency choke point potential plus VCC. Collector capacitor CFC. This is an NPN transistor with common emitter configuration, R1 R2 as voltage divider to provide proper biasing. Necessary biasing conditions are provided by R1 R2 voltage divider. RE is connected to that of bypass capacitor, as bypass capacitor is used to reduce the voltage drop across RE. If we are not used that CE, then a huge voltage is dropped across RE, so power obviously lost. For that reason we use bypass capacitor CE across that of emitter. Further two capacitor at collector and base, these two are called the coupling capacitors, means the output of one thing is connected to the input of another circuit, and that type of capacitors are used basically blocking purpose. Blocking in the sense that capacitor allow the AC current throughout this and block DC. RFC, radio frequency choke, we use in order to obstruct AC current and allow DC current. That one is just opposite function of capacitor. Now we use the feedback network Here we use the feedback network as a tank circuit. The tank circuit is the combination of inductor and capacitor. The tank circuit is the capacitor, inductor, L1, L2. These two are connected in series. Either these two are different, or from a single inductor we partitioned it L1 and L2 and center tapped it. And capacitor connected parallelly to that of inductors L1 and L2, as L1 and L2 are connected series with each other. Grounded. It is the output. Is measured across this. This one is the circuit diagram of Hartley oscillator. That portion is the amplifier portion, this one is the feedback portion, and that feedback portion LC circuit, which we called as tank circuit, tank circuit. Why tank circuit is used? As that amplifier, when input signal is given to that of common emitter configuration amplifier, at output we obtain 180 degree out of phase. Again, to obtain sustained type of oscillation, the entire phase shift around that of loop either 0 degree or it is an integral multiple of 2 pi. Therefore, an additional 180 degree phase shift is required, and that additional phase shift is obtained by using LC circuit. LC is the tank circuit. We have already known how tank circuit is used to obtain an wave. If VCC is applied across that of base, that collector obstruct DC and allow AC. Throughout that of collector we have the output signal, and the capacitor now charged. One plate of that of capacitor is positively charged, another one is negatively charged. Therefore, the current flow from positive along that direction. If that one is positively charged, this one is negatively charged. Current across L2. Now a magnetic field is created. Due to that of change in magnetic field, an EMF is induced across that of L2, and the direction of flow of current now just opposite. In this way it produces an oscillation. That type of oscillation is produced throughout that of tank circuit. As we arranged L1 and L2 as center tapped, so it produces a phase shift of 180 degree. As a result, overall phase shift throughout that of loop is 360 degree, 180 degree phase shift due to that amplifier, 180 degree phase shift due to that tank circuit. Therefore, by using Barkhausen's criteria, we obtain a sustained type of oscillations at output. The working we can understand easily. When voltage plus VCC is applied, the capacitor C is charged. When the capacitor is fully charged, it discharges through the inductors L1 and L2, and the oscillations are produced. The oscillations across L1 are applied to the oscillations across L1 are applied to the base emitter circuit of the transistor and appear in the amplified form in the output circuit. The output oscillations across the amplifier appears across L2. The oscillations across L2 are feedback to L1 by L1 L2 voltage divider. The transistor provides a phase shift of 180 degree between the input and output voltages, and a further phase shift of 180 degree is provided by L1 and L2 voltage divider. 180 degree phase shift from that of amplifier and 180 degree phase shift from that of tank circuit. Thus, the net phase shift around the loop is 360 degree. In this way, the circuit provides a positive feedback to that produce continuous undamped oscillation in that of tank circuit. So, finally, we obtained at output a continuous sinusoidal oscillation. In that type of Hartley oscillator, the frequency of Hartley oscillator frequency of oscillation nu is equal to 1 divided by 2 pi under root of LC. As we are dealing with tank circuit, that is the frequency response of tank circuit. Here frequency 1 divided by 2 pi C, the net inductance of L1 L2 plus 2m. 2m is the coefficient of mutual induction. And the process of mutual induction occurred due to that of induced EMF. That one is the frequency response of that Hartley oscillator. Here m, coefficient of Hartley oscillator, sorry, coefficient of mutual induction. Now we are proceeding towards advantages as well as disadvantages of that kind of oscillator. Advantages: it can be used over a wide frequency range. That wide frequency range by varying the values of L1, L2 and C. If we change the values of L1, L2 and C from that of mathematical expression, we are used that type of oscillator in a wide frequency range. It is easy to operate because of its convenient use in tuning purpose. It provides constant amplitude tuned over that frequency range, constant amplitude tuned. It provides good frequency stability. These are some advantages of Hartley oscillator. Its disadvantage: it is not suitable where pure sine wave is required. Why? Because the output is rich in harmonic content. At output, if we obtain that of sinusoidal wave, but that sinusoidal wave also contains the harmonic distortion. For that reason, we call it is not suitable to obtain pure sine wave at output. It can't be used as low frequency oscillator since the value of inductors are large, as the inductance here will be large, so it can't be used as low frequency oscillator. Next disadvantage: it is bulky due to bulky shape of inductors. These are some disadvantages of Hartley oscillator. Next, applications of that kind of oscillator: it is used as local oscillator in radio and TV receivers. It is used in function generator. Next, it is commonly used in radio frequency applications. These are some advantages as well as disadvantages with applications of Hartley oscillator. So, with the help of this video lecture, we understand Hartley oscillator construction, working, frequency of that type of oscillator, advantages, disadvantages, applications. So, with this useful and informative notes, let me wind up the session. Thank you.